So the power rule states that if we have a function f of x and it's just any number x raised to the power n, where n is any real number like 1, 2, 3, 4, 5 that's whole and positive for this proof, and that derivative f prime would be just n times x to the power of n minus 1. Now, to prove this, let's try to put this in more fundamental derivative notation. So if we were to write a normal derivative of this, we would write the derivative would equal your normal function x plus a little bit plus, oh wait, whoops, I have to write the limit first. The limit as h goes to 0. It's not a derivative if it doesn't have a limit in it. Alright, the limit as h goes to 0 of your function plus a little bit h, and that's raised to the power n minus x to the n, and that's all over h to find the derivative. Alright, so how would we simplify this into n times x to the power of n minus 1? Well, first of all, we can look at this expansion, and we can do it right here. Because if you look at this, x plus h to the power n minus x to the n, it's basically the same formation that we have right here. So we can basically transform this top portion over h into this formation, where a is our x plus h, so x plus h is our a, and then x is our b. And so we can just put it in this. So then, if we do that, it becomes this. So our first term, x plus h minus x, that is just x a minus b, because a is just x plus h, and b is just x. So that's the first term. And then the pattern repeats. So a to the fourth, it would be a to the third, it would be the exponent of your a minus 1. So that's why it's this ra minus 1. And the next term is just a squared times b plus, and it keeps on going like this. And we have that right here with dots, dots, dots. Alright, so to simplify this, we can first simplify this first expression, x plus h minus x, that's just h, x plus h minus h, that's just h. And also, we can see that we have h times something divided by h. So we can just cancel out these h's. And this is all we have left. This top function right here, when h approaches 0. Now, what we have to do is we have to plug h into this equation. We have to make it equal 0. So then when we do that, we just cancel out all the h's. Boom, boom. And now we just get a sequence of x. We just get a repeated sequence of x to the n minus 1 plus x times n minus 1 plus x times n minus 1. And this repeats, because if you look at this first term, it would just be x to the n minus 1, and if you look at the second term, it would be x to the n minus 2 times x. So that times x would reduce that negative 2 to negative 1. And the next term would be x to the power negative 3 times x to the second. So those would cancel and would just leave x to the negative 1. And so obviously this term is x to the negative 1. X to the n to the negative 1. And so all of these, if you count up all these terms, it would just equal n. It would be n terms. So it would be x times n times x to the n to the negative 1. It is n terms because that's how this distribution works. Look, if we have 4 as exponent, we can see 1, 2, 3, 4. If we have 3, we can see 1, 2, 3. So the number of terms in this binomial expansion would just be the exponent. And so that's how you get the power rule.